Hey guys, it's Omar, and I thought that I would walk through the text classification lab while I was doing it. This is the first time I'm doing it, so there might be a lot of back and forth. I didn't pay as good attention to the lessons as I should have, so my outline is not really complete. I'm going to refer back and forth, so let's just, I don't know. I thought I'd just do it, and then we'll see. Alright, okay. We've already imported the libraries, and then blah blah blah. It's gonna try to get a data set that I guess is part of NLTK by default. So I already did this part, categories, and make a list. Then we get the training data and the test data using the method they say. Pretty straightforward. Okay, now let's break apart and inspect. Alright, that's also pretty straightforward. It's what they said. You just get the method, get the list. Finally, let's check the shape, and then you do the shape. Alright, so this is where I got up to. Was here, cleaning and pre-processing. And there's a bunch of spiel questions we need to ask. Okay, now in the cell below, get all the English stop words. So that's pretty easy. We have to import stop words from NLTK. I don't know if they already did that. They did. Alrighty, so we're going to go down to, and then just hit enter on that, specify the language that we need the stop words for, and I got it. Great. We'll leave these for now. Let's tokenize our data set. In order to save ourselves time, we'll write a function to clean our data set, and then use Python's map to clean every article, okay? In the cell below, complete the process article function. The function should take in one parameter article, tokenize the article using the appropriate function from NLTK, lowercase every token, remove any stop words found, and return the results. Oof. Alright. So, for tokenize, and I think they already did it, so let's tokenize. Right, I'm going to paste over what I have. Okay, instead of that, we're going to do article. And then what we need to do is lowercase everyone, and remove any stop words. Hang on, I'm going to refer back to, I already did this, I remember this, okay. Okay. Sorry, I have an annoying little bird here. Here, say hi. Say hi to the people. Hello, I'm a birdie. Come, sit. Don't bother me. Alright, we're going to do... Yeah, it's going to be a lot of pauses because I have not done this. Okay, stop word list. Okay, so this is how they did it there, right? Okay, this is in the lessons. In one of the previous labs, that's what they did. And then they, if word is not, okay. And then to get a list of the words that are not in there, that's what they did there. And then they did something where they remove, okay. What does tokens come back as? I forgot. I want to see something. Hang on. Word tokenize. Does that return a list? Okay, returns are tokenized. Copy. Alright, let's just try it. Okay, and then tokens is equal to, let's just paste over this, right? Hang on. Do we need to add punctuation? Okay, we're not removing punctuation. Or we're not doing, okay, this was to remove punctuation. That one is to remove digits because digits are not stop words by default. So we're going to say tokens is word if not found there. Well, first we have to lowercase it. Hang on. Oh, we could just do that in there. I think that's part of string, the string module, right? Hang on. Python string module lowercase. Okay, common string operations. String.ascii, string.lower. Is there a way to do it? Come on, damn it. Get your butt out of my face. Okay. How did they do lowercase? I don't even remember. Ugh. Damn it. Maybe I could just do word.lower? Hang on. str.lower. String.lower. Okay, the lower method. Yeah, you could just do that. Honestly, why do I need the string module then? I don't understand this. Right, okay. Into a lowercase strings and returns it. It's word.lower for word in Macbeth. That, or not Macbeth tokens, I'm sorry. I need to change that to article. If word is not in stop words, that sounds right. Okay, so lowercase everything, remove the stop words, and then return the results. Okay. Return tokens. Should do it. Alright. Go ahead and process moves. Use Python's map to pass in two parameters, the process article function and the data. Okay. Okay. You know what? I'm gonna take a second and I just want to take a look at what the hell data is. Alright. I'm kinda curious. Type data. It's a list. Okay. Okay. Hang on. So we have data and target. Just gonna okay. Let's just see what the hell is in there exactly. Ooh, it's too big for you, eh? I don't know. Let's see. Okay, SEAL Team 6 should have handled it. Delta Force had more equipment. They did not. Oh my, the language in here. Okay. Man, what the hell did I get? Okay, so it's a string. So it's a okay. Let me just get one more. Okay, let's get the first three. Okay, good. So that's item 1. And I'm assuming at some point it commas it out. There's a new one or something. Okay. So it's a list. So I'm going to now just experiment, and I want to see if the tokens function is working. And we're gonna do tokens test is equal to process article, pass in the article. Let's make it data 1. Okay, threw an error, of course it did. Resource what? Are you... Man, this is annoying. Okay, let's try that then. I'm gonna then do... Oh, is it because it's... I don't know what it is. Okay. Let's just do that. Okay, it's downloading it, and now it's working. Okay, well, let's try again. Ah! Look at that, it worked. I'm sorry, baby. I'm sorry, baby. I'm sorry, baby. Okay. Print tokens test. And it's empty. Why the fuck is it empty? I'm sorry. Why is it empty? Okay, I don't know. Oh, because it should not be empty. Why is it empty? Why isn't it doing it? Tokens is equal to word.lower for word in article if word is not in stop words list. Okay, I'm gonna try something else. Word tokenize data 1. That's also empty. Why the fuck is it doing? Maybe. No. It would already be. Why is it doing that? Why is word tokenized 1? That should work, right? I mean, it'll give me the stop words and it'll be the most frequent, but why is it doing that? Do I need to go? Okay. Word tokenize returning blank list. Yeah. Okay. For some indexes. Sequence of IDs. Can accept sequence single. Okay, for index. Maybe that's why? Hang on. Okay. Alright, let's try this. Okay. Print data 1. Print data. What is going on? Why is data let's, you know what? I'm gonna just, okay, let's restart and clear output. Let's run it all again. And let's go back up to where we get data. Okay, cell run all above. Sorry, baby. Alright, fine. Okay. We're gonna run all above. Come on, god damn it. I'm sorry for the long pauses and stuff. I'm not gonna edit this because it's way too time consuming. Okay, alright. Okay. Okay. Let's check the shape of our data. That sounds correct. Okay, let's stop words. Okay, let's print data 1. Maybe because there just is nothing in there. Maybe that's what it is. Maybe the first is actually empty. Maybe that's oh, okay. So let's try this then. Alright, I should have done that to begin with, you know, because I'd already tested it, so I don't know why I went with the earlier index number. Alright, okay. I don't know why it's doing. Okay, it's already up to date. Alright. Oh, haha. Why is it doing all the letters? What in the fuck? Hang on. Word tokenize. Why did it do that? Why did it do that? Hang on. Is that the whole list? That's not cool. That just looks like the goddamn alphabet. But there's multiple What is going on? Okay, hang on. What am I doing wrong? Okay, hang on. Frequency tokens. Word.lower for word and Macbeth tokens. Raw. For word and article, if word not in. Hang on, hang on. Hang on. Okay. Okay, hang on. Okay, let's do this. Okay, well, we've already done that. Let's ask Google. Word tokenize is returning single alphabets. Okay. Because set tokenize return string iter tools exhausted your combine. I don't think that's okay. Okay, well, let's test to see if this is actually a problem with the thing, or if it's, does it have to be article.text? No, well, I'm passing in a string, right? So let's do, okay, let's just do word tokenize, word tokenize, data 1. Oh, again, sorry. Okay. See, that worked fine. So then what am I doing wrong? Doing something wrong. So we pass in the article, right? Word.lower for word in article if word not in stop. Okay. Oh! Ugh. Such a... Okay, that's what I was doing wrong. Okay. And... print... tokens test. Ha! Ha ha! Yay, that worked. Alright, so they've been lowercased. And it looks like it's shorter. There's no the, so there's an I. Shit, that's not a stop word. There's another I. Why is there multiple I's? I don't understand this. Why do we have more than one I? It's token, so it should only be like once each. Okay, but I'm not seeing the or okay. Alright, so let's keep moving. In the step below, use Python's map function and pass in two parameters, the process article and that. Make sure to wrap the whole map statement in a list. So list map what does map do? Does it go like okay, list okay. Should probably I think map goes if you give it an iterable, it'll go through each item in the iterable and apply the function. Alright. Two parameters. Which one comes first? I'm going to take a quick look at Python map. I think it's worth just taking a quick little peek. Okay, function and then the iterable. Okay, map object. Okay, it returns the thing and then you have to list it. After applying given to each item, given iterable. That sounds correct. Okay, list, tuple, etc. So we're going to map process article and we're going to give it data? Oh, data, right, okay. Ready? And it's taking some time. How you doing, baby? How you doing, baby? Alright, it's poopy time. Come on, let's go. Let's go. Let's go. Good boy. Good boy. Here, go sit. And get off, get off, get off. God damn it. Alright, and that happened, and alright, so that looks good. Why is there Idaho? We really should have cleaned this for punctuation. I don't know why we didn't do that. Whatever. Okay, now let's move on to exploring the data set a bit more. Let's start by getting the total vocabulary size of the training data set. Do this by creating a set object and using its update method iteratively add each article. Since it's a set, it'll only contain unique. Okay, there we go. Okay, so we were gonna do that. So I guess tokens by default, I don't understand. Create a set object. Can I just, how do I create a set? Just do that? Is that a thing? Yeah, I can, okay, hang on. Type total vocab. That is a set. Alright. Oops. Okay. Iterate through each tokenized article in process data and add it to the set using the sets.update method. For item in process data, set.update. Okay. Just okay. Or just item. Wants to get the total number of unique by the length of the set. Print len. Set. Okay. What? Ew, it requires a set, but okay. Okay. Okay, not a problem. We'll just convert that to a set. Right? What? What? Oh. I'm such a moron. Ah! I'm such an idiot. Vocab, print length of total vocab. Okay, it's 47,000. I'm curious if I was to make this, like, remove this, would that work? Okay, if it's working, just leave it alone. Great, our process data sets contain 46,900 No, it doesn't. It contains 47,157. Why do I have an extra 170 words? Did I not take the stop words out? Yeah, the is in there. Oh, that's not good. Oh, that's not good. Doof. Word.lore for word in tokens if word not in stop words list. Because it's not defined at that point. Well, because it's not in the scope. Maybe I need to pass it in, or maybe I need to I feel like this has to be passed in. Can a function access a variable that's not defined within it? It's like a scope issue, isn't it? Let's see. Stop words list. Okay, I'm gonna just pass it. Well, I think you can't, because why else would we be needing to pass stuff in there? So stop words list. Okay. Computer, shut up. Okay. All right, let's try again. Stop words. Oh, right. List. Wait, did I do it correctly? So the function is now a little bit different from what they want, but well, let's see if it even works, right? It's still got the in it. God damn it. For word in tokens if word is not in stop list. It's exactly how I did it for the Macbeth lab, and it worked fine over there. I'm going to go look at their solution. Yeah, that's how we did it. What the stop words list. Did I do it right? Hang on. See that? Well, they're in there. Print the length of it just to see. Yeah, 108. Yeah, that's exactly about as many as, yeah. I don't know why this is not working. Maybe I should just restart the damn kernel. It still has the in it. What the? Let's try this. It's not working. Why is it not working? All right, I'm going to pause for a second and figure this out. Okay, I figured it out. So I made a few changes and now it works better. Oh, no, it's working. So we do tokens is equal to this, and then for tokens 2, we're going to do I.lower for I in tokens if I not in stop words. So I changed from words to I. Maybe that helped. I also did one other thing is if I dot lower. So we want to, that's going to take out more of the stop words because some of the thes are capitalized and so on. So let's see now. Hang on. All right, yeah, so that's what I did. I'm going to do that, and then just to test it, I did it outside the function, but now let's do the test again. Process article there, and then if we print the length of test, it's 284. Hang on. See? That was when it was just taking out just if I not in stop words instead of I dot lower. And now it's 262 because we're taking out the word even if the lowercase version of the word is found in stop words list. So, and then we're going to just print test itself. And yeah, you see that, yeah, it doesn't look like it has thes. But if you want to double check, so we're going to do print the length of data 5. And you'll see that that's 2,305. So after taking out the stop words, oh wait, no, print the length of tokens, because so up here I just did word tokenized data 5, right? So it's basically doing what this line does inside the function outside of it. And hang on, let's do that. Okay, and then if we print the length of that tokens list, which is like all the tokenized words without the stop words taken out, it's 494. And after we take out the stop, so we know that it's working, basically, is my point. Let's just go down and try again. Process data ready. So again, I'm going to take a second. I'll just pause. All right, it's done. Let's look at the first article. Okay, there we go. Looks like it doesn't have any of those. And then we have the same, the set, and I think this part is fine. 47,024. God damn, we're still like 24, 34, 35 words, 34 words above. Why? What are we doing wrong? Hang on. Okay. I don't know why it didn't take out those 35, but I'm just going to keep going because I don't know. You know what? Maybe they updated the data set since they wrote the lab. I have no idea. Shut up. Be quiet. Okay. Process. Concatenate single list and pass it to frequency. Okay. And then pass this into frequency distribution. Create an empty list called articles concat. Okay. Iterate through process data and add every article it contains to articles concat. Okay. Okay, and add every two articles concat. Oof. As a one huge string or as a separate article? Okay. I think they want one huge string because they are going to do the frequency distribution to see which words are used the most, and I'm assuming that they want to do that for the whole corpus. Every article into a single list. So what the hell does that mean? Pass this list into frequency distribution into a single list of what? Tokens? Or hang on. Well, top 200 most used words. I'm gonna guess that it has to do with okay, I'm gonna pause for a sec. Okay, so I went back to the lessons. I'm pretty sure what they want is one giant list where each element is every word from like all the articles. So basically right now process data is a list of lists where each list within the larger list is the list of words for the article. So they just want to smush that together, have one giant list of just words. To do that, what we're going to do is for item in what is it? Processed data. So just hang on. For my sanity, I'm gonna do type processed data. It's a list, and then we're gonna let's just do a print processed data. The first, just the first two. Yeah, it's a list of lists, right? So each sublist is like, oh, this is all the words in the first article, and then, this is all the words in the second article, and so on. That kind of thing. So what we're going to do is for item in process data, right, for each list in the process data list, articles concat, let's try this. Well, should work. Plus equals item. That should do it, because you can add two lists together. We could have written this as equals, articles concat plus list. That'll just merge the two things together. But I want to do plus equals item, and let's see if that works. And then I'm just gonna display articles concat. Okay, so it's one list. That's a good thing. And then we want to print the length of it, and this should match. Okay, 553,970. Okay, because it's every word. It's not just the unique words in each article. It's every single word in the whole article, with the exception of stop words, I think. Right, yeah, okay. So now let's just do that as the frequency distribution. Pass that in there. Pass what is it? Articles concat. Stop eating stuff off the floor. Hang on. Alright, sorry about that. Alright. Shut up. Be quiet. Don't be noisy. Okay. Okay, that should have done it. Let's display freak this. It's not defined. I'm sorry. Display this. Or let's just print frequency distribution the first 50. What do you want? Oh, it's on Haskell. What? Because it's not a list yet. Because right now it is a something. Okay, hang on. Pause. Okay. Let's just do dot, because you have to do dot most common 50. And hey, look at that. Okay. The punctuations are the most common. I really think we should have taken out punctuation and numbers. Greater than signs. Why did they not ask us to take out punctuation? Should I take those out anyways? Maybe if I do that, that'll bring the count down to 46,990. Let's try that. I'm going to pause. Okay, so yeah, I was supposed to take the punctuation out. I completely did not read this, so you got to stop and read the instructions instead of just going into it willy-nilly. Totally my bad. Luckily we caught that. And yeah, sure enough, when I did all of that and then I do the set, I have 46,993 unique words, which is still 3 more than what they said, but come on guys, it's close enough. Leave me alone. Alrighty, let's go down, and we're gonna. Okay, let's do these again. We don't want that. Okay, put the length of it. Okay, probably because we took the stuff out, and I think it's because maybe we still have like this thing. And single quotes are not, maybe those are not in punctuation, string not punctuation, but, okay, so whatever. Apostrophe S and apostrophe T, 1, 2, would. Makes sense. People also makes sense, because this is, alright, okay, so that's interesting. Government, window, alright. At first glance, none of these very informative, represented, tough to guess, equally 5 disproportionately makes sense, okay. This tells us that these words are probably the least important, as they're most likely the words that are used across multiple classes, thereby providing our model with little actual signal as to what class they belong to. This tells us that we probably want to focus on words that appear heavily in articles from a given class, but rarely appear in articles from other classes. You may recall that this is exactly where TF-IDF vectorization really shines. Yay, okay. Although NOT provides vectorizing, we'll make use of scikit-learn's vectorizer because we already have experience with it and because it's a bit easier to use. Models feeding into it from what? When we feeding the vectorizer or from scikit-learn, we wouldn't have to worry about doing extra processing to ensure that they play. Fair enough, as you wish. Recall that in order to use scikit-learn's blah, we need to pass in the data as raw text documents. The vectorizer handles the count vectorization process on its own, then it fits and transforms the data into TF-IDF format. Okay, import that and instantiate. Did we not already import it? We already imported it, so we don't need to do that now. We're going to just instantiate it. Okay. Okay. And instantiate TF. I'm just gonna paste it. I really hate typing stuff, guys. Okay. This is fun. This is like Twitch. Okay. Call the fit transform, pass in our data as input in train. Okay. Vectorizer.fit transform data and do the same for test, and we're gonna paste that in there and do test, and let's go back up here. Ready. Okay, that went off without a hitch. It's interesting though, because don't they take out stop words? That's alright. Now we have pre-processed and explored our data set. Let's take a second to see what our data looks like in vectorized form. Okay, let's get the shape of it. Dot shape. What do you mean it's not? TF-IDF data. Dude, train or test? Which one? You didn't specify. Were we supposed to have one? Did I miss something? No, I think they missed it. Okay. Okay. Tuple object is not callable. What? Use the transform, not the fit transform. Wait, hang on. When using the test data, do transform. Okay, I need to stop and read this stuff. Fit transform, pass in data. Okay. Also create a vectorized version of our testing data, which can be found at newsgroup test. Store it in here. Okay, which we already captured that at some point as test, I believe. Yeah, we did subset and all of that. So we already have this, or do we? Yeah, we do, because we test and then dot data, right? Because we did it. Okay. Okay. Now what is this now? Oh, alright. I should know this by now. Contains 2,814 articles with 36,622 unique words in the vocabulary. However, the vast majority of these columns for any given article will likely be zero, since every article only contains a small subset. Okay, vectors are referred to as sparse vectors. These are extremely common when working with text data. Okay, let's check out the average number of non-zero columns in the vectors. Average number of non-zero columns in the vector, each vector being the row. Okay, right. Okay. Run the cell below to calculate the what are they doing? Okay. Non-zero columns equal to dot nnz. I don't know what that is, so I'm not even gonna. Something non-zero, right? Number of non-zero, is that what it is? Okay. Over float shape, so the total number of columns. Okay, I see what they're saying. Maybe. Non-zero percent sparse. Alright. Average number of non-zero elements in vectorized articles is 107. So it's like 107 words per article on average. Percent of columns containing 0, so that means 99. Okay. I don't know what that means. Does that mean 99% have 0? Oh, so there's no column that has every value filled. 99% of them have 1 or more 0 in them. That's what that means, I think. Okay. As we can see from the output above, the average vectorized article contains 107. That's what I said. Okay. 99.7 of each vector is actually 0. Okay. Oh, is that the average? Okay, I don't know. This is one reason why it's best not to create. Oh, okay. It's best not to create your own vectorizers and rely on professional packages such as scikit-learn and NLTK. They contain many speed and other memory optimizations specifically for dealing with sparse vectors. This way we aren't wasting a giant chunk of memory on a vectorized dataset that has valid information in only 0.3. Okay. Now that we've vectorized it, we just want to fit them to our vectorized training data. Alrighty. Instantiate multinomial NB in random forest classifier. Ooh, fancy. I don't know what that is. They mention that in the lessons? Okay, that's fine. And random forest classifier. You got it, boss. Okay. Set n estimators to 100. Estimators is equal to 100. Okay. Fit each to our vectorized training data. Okay. NB classifier dot fit to our training data and what? Okay, hang on. Training labels stored within the variable target and the test labels stored in test.target. Are you sure about that? I don't mean to doubt you, but I just feel like I want to take. Oh, yep, we did that. Data is this, and target is okay. Data target, and we want to do. Alright, and we have fit them, and it will take some time, and we have an error. What is the problem? What? Reshape your data either using or single if it contains a single sample. What? Why? Oh, maybe because I need to put. Oh, wait. No, that's the vector. It's the vectorizer. We have to pass in the vectorized data. My bad. My bad. Okay. Okay. Fit each to our vectorized training data. My apologies. But target will be the same. Yeah. No, it will not. What do you mean it's not callable? Oh, my bad. And that, please work, please work. Yeah, it's working. It's going to work, it's going to work. Look at, oh, yay, it worked, yay. Okay. Fit each. Create predictions for our training. Okay. Wait, what? Okay. Hang on. For our training and our test sets. Using which one? I don't get it. Wait, I don't understand. Which one do you want us to fit? The NB multinomial NB or the random forest? I'm just gonna go with. Hang on. What? Dude, I really gotta read this stuff. Hang on. Okay. Fit each. Oh, because it's. Oh, I see. Okay. 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 No, 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 no. Oh, maybe. Oh, okay. Hang on. I see what's going on. Let's try it. Okay. Let's just fit up here. And we're gonna do. Okay. That is a much better. Okay, so that's going to be dot predict for our training set. That is this. Did we store somewhere what the testing data was going to be? It probably says that. I'm probably wasting time. Oh, okay, right. Hang on. Okay, it says, right, it was saying that, and I should have listened to it. It said that at some point. Right, it said, you'll find your labels stored in the test labels. Training labels associated with the variable target, and the test labels use test.target. Okay. So that means that we will do newsgroup test and then test.target. I think that should do it. Yeah. Because newsgroup test is we stored that and dot target. Okay. I think that's, yeah. Okay. Okay. Oh, let me just change that really quickly. And B. Ready. And dot predict. My apologies. Many apologies. $10 if you know where that's from. Okay. Let's try that again. Let's try it again. Let's refit. Okay. No. Oh, wait. Oh, I don't need to pass in target because we're predicting. We just need the data, the features. That will be the prediction, and we'll, to get the scores, we then pass it. Okay. I need to slow down and read stuff. I'm going way too fast with this stuff. I need to lay off of the caffeine. That's what it is. It just wreaks havoc with my sleep schedule, makes me all cranky, then I get into fights. Not a good look. Okay. It's still throwing an error, isn't it? You little frick. No. What am I doing? All right, I'm going to pause and just get my shit together. Okay, so again, yeah, I did not read the instructions, and they explicitly said when transforming the data, use the transform method on the test data, as the vectorizer has already been fit to the training data. So, okay. Yeah, for some reason on testing data, you don't fit transform because I don't know why. I for whatever reason. Hang on. Actually, no, I do. Maybe I do know why. Because I found this. I went to Slack and it says this guy had the same problem, and he says your account vectorizer has already been fitted with the training data. So for your test data, you just need to call transform, not fit transform. Why? I wonder why that is. I don't know why that is. Otherwise, you could use fit transform again on test data, different columns based on the unique. Is that what it is? Because I don't know what I don't understand. Okay, this I think I need to think on this a little bit more because. Okay, so the vectorizer takes the data and it transforms it by creating a column for each word within that. So if we do fit transform on the test data, something weird is going to happen. I don't know. You know what? I don't know. I don't know what's going on. But that's so just when you're using vectorizer on your test data, don't do a fit transform, just do a transform. Maybe James will shed some light on this in the study group. It's definitely a question that I want to ask. Okay, let's try that now. And it's still not working. God damn. Hang on. I just didn't run the cell. Okay, and we're going to do the same thing. Predict. Hang on. Okay. We're going to pass in the same data here and then the same test. Okay. And we're going to do that, and then let's do the accuracy score. Okay. Both the training and the test and the labels associated within. Okay. So to find the accuracy score, we're going to say NB training, so that's going to be NB train dot underscore. What comes first, the actuals or the. Hang on. Okay, yeah, so Y true comes first, so it's going to be, you will find our training labels stored within the variable target. Yes, that's very true. Okay, and let's just do the same thing for our, that's going to be, no it isn't, because it's going to be that one. And for the test, it's going to be, it's going to be not target, but it's going to be test, right? Because we, okay. Dot target, fair enough. And paste that in there, and that's going to be nb test dot preds right there. Maybe it wouldn't kill me to type stuff out every now and then. Okay. Paste that there. Oh. Control C, dot target, and then RF, right? RF. And let's see now. Of course we had a problem. What problem? Found variables with inconsistent numbers. Okay, I give up. I don't know why it's giving me this error. Hang on. What I tried to do was just look at the training scores. For some reason the testing scores, it's not fitting right. So I don't know what is going on there. Line 8. Where in line 8? Okay, hang on. Hang on. Yeah, it's giving me this found input variables inconsistent with number of samples. I don't know what that means exactly, but it's the last damn cell, so it's so frustrating that I have to look at the answer now. But, so what are you going to do? Sometimes it is best to swallow your pride and admit defeat and call it a day, because there's limited amount of time. So we're just gonna hit I'm done and then look at the solution. And I mean, in fairness, like, I did almost all of it, right, till except literally the very last cell. That's exactly what I did, right? Yeah, that's exactly what I did. I don't know why. Let's do a comparison just to be sure. Okay. Okay. So let's see. Right? It's the same thing. Right? Target NB preds newsgroup underscore test dot target, and okay, I did that correctly. So then what's the problem here? Did I do test preds correctly? Oh, it's RF classifier dot fit. Okay, did I fit it to the correct thing? Yeah, TF-IDF data target. Okay, I did that right. Dot predict, train, and test. Yeah, that looks like I did that right as well. So then it's all correct. Then what's the problem? Did I not vectorize them correctly or something? Hang on, let's go up. Okay. Yeah. Oh, I see. See? Okay, well. No. Okay. Okay, so that's what I did wrong. It's newsgroups underscore test dot data. Did they tell me to do that? Fit, which can be found in newsgroups. See? Okay, lesson learned, guys. Read the damn instructions closely and carefully, and don't skip over them because you think you're so damn smart that you don't need it. It's right there. I don't know why I had to do that, because you would think that... okay. I think I know why. Because we never, early on, when we declared them, we got the data for that, but we didn't get it. We just had a variable for test, right? But we didn't get the dot data and store that in a variable. So that's what I did wrong. Okay, minor mistake. Otherwise, not bad. Pretty decent lab. All right. Well, I hope that was helpful, and I'll see you guys.